Hi everyone. So today I'm covering C in depth book first chapter. In the chapter name is introduction. So firstly we there can be questions that came into mind of many people. बहुत लोगों के दिमाग में क्वेश्चन आता है कि हमें ये लैंग्वेजेस चाहिए क्यों? जैसे हमारे पास लैंग्वेजेस हैं हिंदी, इंग्लिश, पंजाबी. Every states have their respective regional languages. So why we need these languages like C++, Java, Python, like that. So usually like computer understand 0 or 1 as we know, like because computer is made of hardware, involves registers, your arithmetic ALU arithmetic logic units. Okay, so these hardwares understand this motherboard and all, they are made from registers, your flip flops, okay, arithmetic logic units. So all these hardware only understand 0 and 1. Okay, so it don't understand your Hindi language, your English language, your Punjabi or whatever language we know. Okay, so we simply want to communicate with the machine. Okay, so to communicate with the machine we have developed lot of languages like C, your machine language, your assembly language, etc. Okay, so C is one of the language. It is middle level language. Okay, and it is very popular language. Okay, and it is used at lot of places. So basic idea of why we need language is to communicate with the machine so that we can give some instructions to the machine and that instructions can be fulfilled by that machine. So that's why we need languages is. Okay, hope you have understand that. So now uh, we will say usually we have a one C program. Okay, in that C program usually there are set of instructions. Combination of instructions form a program, and combination of program collection of programs form a software. Okay, so before writing a program there is various steps involves in order to work before writing coding program coding. There is a lot of process of program development, right? There is various steps involved. Like firstly we check feasibility, whether our idea, whatever idea we are trying to make, whether it is feasible or not, whether it is feasible or not, or feasible भी है या not. Okay, then it comes user requirements. Feasibility, firstly we check the feasibility, then we go for user requirements, like what are the requirements for that particular program. Okay, afterwards we go for designing. We do HLL, high level design. So in that high level design we make we design how our software will look like, how our program will look like, how we can make it scalable, what are the things we should use, and all everything. We make a high level design. Okay, then we go for a program coding that involves low level design. Okay, so and then involves your user unit testing, integration testing, quality assurance, so that we can test our written code whether it is meeting all the required functionalities, all the user requirements which we have taken, whether it is meeting all those things or not. And then we go for a maintenance. Like with the time we have to add some new feature, we have to make some new changes into existing software or program, so that involves maintenance. And there is one step involves documentation. So in documentation we usually document entire things like how this program start, what are the inputs, what are the outputs, right? So that any user who want to use that particular software, they can read that software and they can use that software. Okay, so these are the various steps involved. So these are the various steps involved. So these are the various steps involved in the process of program development. Okay, so now we will see different designs. Now we will see the different designs like top down design and bottom up design. Okay, so top down design involves your breaking your components. We are dividing the entire software into some major components, and those major components are then subdivided into lower level components. And similarly, so it is like from top to bottom. Bottom up design involves your starting from small components of your entire software, and then keep on combining those small components and forming a big component. Okay, so programming languages. Okay, so what is so these programming languages, these are of two types: low level languages and high level languages. So low level languages are usually machine level language and assembly language. Okay, and your machine level language involves your uh, uh, binary digits. Machine level language works writing all the operations, everything in the form of 0 and 1s. So it is very difficult for humans to understand, to work with zeros and 1. If you have to add, there is some specific code for 0 and 1. If you have to subtract, there is some specific things for subtraction, to perform any arithmetic logic units, right? So there are different set of combination of 0 and 1s which will say particular your operation. So it is very difficult and it is hardware dependent. So then humans develop, go beyond your machine language, and we go for a assembly language. Okay, in assembly language, what we have is, we have some sort of English language words like move, add, subtract. We use these things to perform arithmetic operations or any other data operation. We have some set of keywords for that, and there are usually assembler. There is one translator assembler which convert from your assembly language to machine language, because any, whether you are writing in a high level language or in assembly language, all the things are to be converted into machine code, machine language, which is understood by our motherboard, our hardware, because these are fundamental things, are flip flops and all, which only understand 0 and 1. Okay, so although so assembly language is little easier than your machine code, because it involves some set of English words, but it is also hardware dependent, so it is not portable, because it depends on resistor and all for all of your operations, and those resistors are dependent on machine, and those vary from one hardware motherboard to another motherboard, so it is hardware dependent. Then we come with the third concept of your high level languages. Okay, so high level languages like your C language, C++, Java, your Python. Okay, they all are high level languages, so these are independent of your machine. These are independent of your motherboard, your hardware, your machine. Okay, so here what the and they are more easy to understand. So here the most work involves to the programmer is to build the logics only. It's easy to learn their keywords, how to write the languages, compared to assembly and your machine languages. Okay, so then these third set of languages came, that we call as high level languages. So this is how the languages evolve as the time passes, as the human intelligence is increasing. So we are evolving these languages like machine, assembly, high level languages. Okay, then we have our translators. Okay, so what are these translators is, like as name says, it translate one form of the things to another. Okay, we have a compiler, assembler, and interpreter. We have these three translators. So usually compiler and interpreter, what they do is they convert your high level language into assembly language. Compiler and interpreter both do the same thing, but they are different in their functionality, that I will discuss with you. So they convert high level language to assembly language, and what assembler do is, assembler converts your assembler convert your assembly language to machine level language, and that machine level language is finally understand by your machine, and they perform the required operation, whatever is being the logic is written in high level language by a programmer. Okay, so now we will see what is the difference between compiler and assembler. So compiler compile entire code, and if there is no error, it will convert entire programming code of C into assembly language at one go, and if there is any error, it will list down all the errors by compiling entire program. But interpreters do read by it checks the error of the program statement by statement. Okay, wherever it get an error, it breaks down. Wherever it get error, it stops and it shows that error, and it keep on converting line by line your code from high level language to assembly language. Okay, so these are the two differences between compiler and interpreter. Okay, so hope you have a clarity what is different between compiler and interpreter, and what usually assembler, compiler and interpreter do. So now we will see the history of C. So usually there are various usually C language was evolved to write your kernels for the Unix, and this is derived from a B language, and yeah, so it is standardized in 1982 by ANSI, and they have usually language, there are standards introduced for C language that we call as a ANSI C. Okay, and generally most of the modern compilers conform to this standard. Okay, now we will see characteristics of C. So C is like, we call it as a high level language, or you can say it a middle level language, and it involves various things like you have a you can perform various functions like there are various keywords like if else, for, break, right? If you want to do some conditioning, you can use with if else, or you can use switch statements. Okay, and C language consisting of 32 English words known as keywords. So there are keywords which are specifying meaning for a C compiler, and so these are 32 in number, and usually C uses compiler, it don't using interpreter. If you think say Python use interpreter, but C use compiler only. Okay, as a translator. So there are various keywords like some of them are mentioned here is like if else, switch, while, for, do, while. If you want to do repeat the things, you can use your repetition can be done using while, for, do, while, for loop, right? If you want to break something, you can use break. Okay, there are some selection structures like if else or switch, right? So now we will see some of the basic structure of C programs. So here you can see basic structure involves your commands, right? And your preprocessor directives, global variables, and your and this is basic structure of a C program. Okay, so if you see here, this is like you can define your commands. These are preprocessor directives, these are global variables which are visible in all the functions. These variables are accessible here as well, here as well, here. Okay, so these variables are accessible in all the functions, that's why we are calling it as a global variables. Now you C function usually mostly start with int main. Okay, and here inside that whatever you defining, these are local variable and these are set of instructions. So if you are defining here int, so you are returning 0 here. Okay, if you are defining here void, there is no need to return anything. You can also return void if the return type is void, there is no need to return anything. Okay, okay, now these are set of functions. Okay, and function 1, function 2, there are set of local variables, statement, local variable and statements. So this is basic structure of C program. So usually if you see delimiters, your comments, okay, comments are usually enclosed in delimiters like this in C language. Okay, your we say your preprocessors, yeah, usually there are directives that are like include and hash define. Okay, and it mostly start with the main function. Okay, and as it is int main, so we are returning 0 at the last. Okay, you can return any other value as well if you want. Okay, and so there are local variables and global variables that I already explained you, that local variables have a scope within the function itself, and your global variables have a scope within all the functions of that program. Okay, so now we will analyze this your entire process, how it works. So you should see here, firstly we have a source code, one program which we have write that is interact with compiler, so that convert it into assembly code. Once it is converted into assembly code, then assembler work on that and it is converted into machine code. Okay, it's converted into machine code, and all these pre-processive directives are already present as a machine code, or you can say it as a object code. Okay, and this object code, so what the linker do, linker combine object code of your source code plus all the preprocessors, right? So these are also present. There are already existing predefined functions which are available in your preprocessors, so those are already present as object code. So once we have a object code of us from our source code, and so linker combine your object code of both preprocessor and source code, and it form a executable code that is finally run by our machine. Okay, so this is entire flow, that how it works. I have explained it in a naive way, so hope you have understand how this entire flow works. Now, so I have explained you all these things, like what is preprocessor. So usually it is set of libraries which is already present in C, and there are already a lot of built-in functions. Okay, so compiler, what they do, compiler converts your source code to your machine, your assembly code, and assembler convert your machine code to your assembly code to your machine code, and linkers your combines your machine code or object code of both source code and from preprocessor source codes are also available as object files. Okay, so linker combine object files of preprocessor and your source code, and it finally form executable file that is run by our machine. So environments of C, so program, so is involving it usually involves program creation and the compilation and then execution. Okay, these are various steps involved. So if you want to run that into your Linux environment, so it's easy. So you can use in Linux environment, create a one file, you can create using Vim or any text editor, and save it with .c, and then you will compile it with .cc, filename.c. Okay, and if your mathematical operation, you can run it like that, you can compile it like that, and finally it will create one output file. It will create one output file, then run that output file, and it's all done. So you will execute your code. Similarly, if you want to run it in your MS DOS environment, or like you can use some ID. Okay, there are IDs available, so it's like usually you should create your program using that ID, and save that program with .c file, and then you can press Alt F9 and Alt F9, it will do the program compilation. Then press your Control F9, it will involves your program execution. Okay, so this is how like I have explained you basic things, like how there will be what is C language. So I hope like in summary I have explained you why we need these languages is okay, what is the basic process for a program development, right? What are various stages in that, what are the various sample like C program looks like, okay, and how to run that program using Linux environment or using ID. Okay, and hope you have got clarity, and if you have some doubts you can ask me, and yeah, we will meet in next chapter.